Dr. Mark Changizi here with your Science Moment. Today I'm going to talk about why physics is so important for high school students and for college students. And, and this is, what really is the point of physics, so one might ask. Now, I obviously everybody understands there's a big point for physics if you want to understand physics and many different kinds of processes. But there's another point for why people should really take physics. And so I was talking to my son the other day, who's 17, and we were talking through kind of the motivations for how it ended up that physics is where it is in high school and in college. And I don't really know the actual kind of history as to how it ended up that way or whether it was just sort of selected for over time without any conscious decision. But, it happens typically during high school that you take math for a few years, you take biology first, in parallel, and then you take chemistry, and then you take physics later when you're getting closer to calculus. Now, you could argue, well, you're just not ready for physics until then anyway, so you do need to know physics because it's important, and you're just not ready, so you should take it then. But there's another parallel argument for why one really wants physics as something that should occur in parallel with the higher level mathematics. And this is true even if one never does any physics later in life or even utilizes per se those physics principles. And what's key, and I don't think I noticed it until I was chatting with my son yesterday, was that, sure, when you do math, there's been a long push for 25, 45, 50 years, I don't know how long, to put real examples, examples that hit the pay dirt so people can understand math and how it connects to the world. Otherwise, you can do all this abstract math, you can memorize all these principles, but until you've really used it in real context with real objects and things that matter in the world, or even thoughts, or whatever it might be, they have to ground out in something that you can explain or describe, then it often just is floating up there and it never means anything to you and is never in fact useful. So what you could do with math is just have tons of problems, which they always have, problem sets at the end of each chapter. So what you would have in that case is hundreds of domains of examples that you can just pull from whenever you want to provide examples for any given mathematical situation. So you're introducing these sorts of kinds of mathematics. Okay, here's a bunch of different kinds of cases where you could use it from all parts of your world. If that was the case, then you don't really have to have high school kids take physics at the same time because they're getting plenty of examples. And they're never going to use physics per se anyway. But here's the counter argument to that. And this is what was new in my own thinking, and I don't think it's necessarily new at all in terms of, sort of scholars of education. And what was new for me was the realization that it's not enough to have examples in 100 or hundreds of different categories unrelated to one another. Physics, what makes physics great is it's one extended, cohesive, holistic example. You're using mathematics in certain parts, and then those parts intersect in certain ways with other parts, and they intersect with other parts. You have kinematics, it intersects with dynamics, which intersects with different kinds of energy terms, and integration and differentiation and differential equations, and all of the things that you learn in math for many years, and linear algebra, all these things that you learn, all of these years in math, are all not only within an example, but within one big example where they all intersect in various complicated ways so that you get this holistic structure of how the mathematics is not just useful in this or that instance, but how they can be pulled together in kind of a unifying framework for understanding large-scale, complex systems rather than itsy-bitsy example here and itsy-bitsy example here. And I'm not sure that I would have ever become the theorist that I am if I hadn't done physics. But again, I thought it was because physics per se was important, and I think it also is. But this other dimension, only through physics did all of that math that I studied in undergrad and in a PhD, as well as in high school, only by virtue of physics did I have this one extended example that just continued over the course of years, making all of that mathematics meaningful, right? Now, you could have a counter argument could be, just as a thought experiment, you could say, well, one could come up with a faux example rather than hundreds of different examples within the math class, where you just come up with some faux universe. It's a fake universe, but you just keep the examples going within that same fake universe, always finding some reason. And you could do that. I'm not sure if it's possible. You can imagine maybe someone could come up with such a thing, in which case it's only by the virtue of the way it all intersects and interacts that you realize where the place of all of these mathematical concepts comes to be useful within that system. But even if you could come up with a system, why do it? Why not just use physics, which is actually useful in physics, and the concepts within physics are in fact useful in all of these other areas of science. So you might as well use something that is intrinsically useful, applicable in many other domains, rather than some made-up one. And that was your science moment. If you haven't seen my earlier book, Brain from 25,000 Feet, it's my very first book. I never talk about it. It is on many aspects of why we see the way we do, why animals scale the way that they do, why brains get bigger in the particular ways that they do, why we think the way we do. Lots of topics earlier in my career. You can actually find it free at my website. Poke around, you should be able to download it. Otherwise, it would be $300 on Amazon. That's your science moment.